Hello everybody, this is Killed the Cat, and welcome to your 16th C++ tutorial. By the way, I was way off on the numbers in the last tutorial. I think I said it was like the 12th or something. But anyway, in this tutorial we'll be going over pointers, which is... it can be a confusing topic, so get ready. But we don't need any of this class stuff for now, so delete that. And delete this. I'll forget I deleted that in the next tutorial when we do need it again. And we will run into errors, I promise. So, a pointer in C++ is kind of similar to a reference in some ways, but it's both more powerful and at the same time more dangerous to use. So, what a reference is it's a kind of just a nickname for a value. So, say we create int x equals 10, and then we can say int and y equals x. So then we can output x and end line, and then we can output y and end line. So if we build this and run it, we get the same value. So a reference is just a nickname for a variable. And a pointer is similar to that, but instead of being a nickname for a variable, it's kind of like a nickname for a space in the computer that's running the program's memory. So the first thing I'm going to show you is the syntax to create a pointer. So we say int, and then we have the star or asterisk. I just call it star because it has less syllables. So we say int star and then whatever variable we want. And some programmers, I should do this, but I'm bad about it. A lot of people prefer to put a p in front of the variable to show that it's a pointer. And if we did that, then we'd have to make this a capital X. Actually, no, we wouldn't. So you'd have px instead of just x. I'll try to do it for the tutorials because it is good programming practice, but I may forget. Sorry. So we say int and px, or in star px, equals, and then instead of just writing 10, and then semicolon to set the value, you see we get an error. A value of type int cannot be used to initialize an entity of type int star, or pointer to an int. So instead of just doing that, we need to use a new command called new. So new space int, and then in parentheses, like we're calling a function, we say 10. So now this should build just fine. So before we move on, let me explain what this new operator does, because it's very dangerous if you use it wrong. You could crash the computer you're running the program on. So when you call this new operator, it looks ahead and sees int here. So what it does is it takes a chunk of memory from what's called the heap, and the heap is basically just the amount of free memory on your computer at the time. So it sees you want an integer, so it'll take the amount of memory it needs to create an integer, and then it'll set that binary data to 10 because you have the 10 in parentheses here. So this variable px, or we'll just call it x, it doesn't hold the value 10. It holds basically the address where that value 10 is stored in memory. So let's try outputting this. So we'll say count px and end line. So if we run this, you'd expect to see 10, but you see 0106C0E0. So that's definitely not 10. That's a very big hexadecimal number. And that number is the address in your computer's memory where this px is stored. And by the way, you will see a different number than the one this number. See, it's even different now than it was the last run. It'll change every time you run the program. Don't worry, you're still doing it right. So this just shows that our variable px is not actually holding a number, it's holding the address in memory where that number is stored. So right now you're probably thinking that you don't care what the address of this value 10 is. You just want to see the value 10. So If you want to output or pass to anything the value of the pointer rather than the pointer itself, you just put another star in front of the pointer, and then if we run this, we get 10. So this is called dereferencing a pointer. It just shows that you're interested in the value, not the address. So there are some errors that are very easy to run into when you're using pointers. The first one is that you can't pass a function that takes a normal value, like an integer. You can't pass that a pointer to an integer. So let's create a function. We will say void. I forgot how to declare a function in C++. I've just been using Lua a lot. So void add. We'll just use our old add function that we've been using a lot. And num1 and num2. And we'll define it here. Why is there an error? Not sure why that's an error. It'll probably go away soon, hopefully. And then we'll define it here. Void add num1, num2. What? Why is it mad at me? Whatever. And we'll just say return. Actually, no, we'll just output it. Standard count num1 plus num2. Now, why are there errors? Oh, that's why. Again, I've been working with Lua, and in Lua you don't need type names. So I'll probably make that mistake a few more times. There we go, now it works. So now let's call this function. I'll just create a new pointer. Actually, we don't even need it to be a pointer. And int, just say y equals 20. So now let's call the function. So we'll say add px and y. So we get an error. It says void add int cannot convert argument 1 from pointer to an int to int. And another one, that IntelliSense error is just saying the exact same thing. So again, you just can't pass a pointer to a value in as a substitute for a value. But again, to change this, to fix this, it's pretty simple. You just dereference it, and it should work fine. So now 30, 10. But if you do want to pass pointers into a function, you just make the parameters pointers. And you don't need to say new num2, because the pointer's already been created if you're passing it in. So pointers to ints, and then we'll need to dereference this. We'll just need to dereference it here so that we'll get the actual values instead of the addresses of the pointers, because you can't add two pointers together. That just doesn't work. So this no longer works, so int star and new int 20. So this should output the exact same thing, 30 and 10. So the last thing we have to go over in this tutorial is why pointers are so dangerous. And to go over this, we don't need this. We don't need this. And we don't need this. So the reason pointers are so dangerous is because you're taking memory from the computer. And in a lot of languages like C# and Java, when you take memory from the computer like this, and then you stop using it, like it goes out of scope or something, then what's called a garbage collector will come and it'll see that that variable or pointer isn't being used anymore, and it'll give it back to the computer. So C++ doesn't have that, so it's very easy to lose memory completely, and that memory will be gone until the program closes. Or if you're not using Windows or Mac, or probably Linux, then I'm not sure what else you would use, then you may lose that memory forever until you turn the computer off. So let me show you how you could make this mistake. So we have px, it's equal to 10, the new int 10. So it's taking a chunk of memory from the computer and setting that memory to 10. But say we do px equals new int 20, that's 30, 20. So that's legal. It'll build, it'll run, it says 20 now, and it may look fine to you, but really this is very bad, because when we set px to 20, then px no longer points to the address in memory that stores 10. It now points to the address in the memory that stores 20. And it's a completely new address. It's not changing the value, it's not changing the memory that stores the value 10 to 20. It's taking more memory and setting that to 20. So you've effectively lost this chunk of memory that holds the value 10. And since there's no garbage collector in C++, that will just be floating there, unable to be accessed unless you make a very lucky guess, until the program ends. So you've just lost memory, and it's only like 4 bytes or 4 bits. An int's not that much memory. I'm not sure exactly how much it is. So it may seem pretty insignificant to you, but if you're using big classes, like in graphics programming, if you lose a texture image, that's a lot of memory that's just being wasted. So you have to be very careful not to do this. And the way we can stop ourselves from doing this is with another new operator called delete. So to use it, we just say delete, not delegate, delete, px. So if we run this, you'll see absolutely no difference. Still 20. But what delete does is it's the exact opposite of new. Instead of taking memory, it gives that memory back to the computer. So we take memory from the computer, we take an integer of memory and set it to 10, and then we delete it, so we give that back to the computer, and then px takes more memory and sets it to 20, outputs that, and ends the program. That memory's still kind of floating there until the program ends, so we should delete px again. It'll build and still do the exact same thing, but we're just closing the program off properly and freeing all the memory, because there could be an error and that memory could be lost until the computer's restarted. So this is a much safer way, or it's not a much safer way, it's really the only proper way to use pointers. If you don't do this, your program will quickly crash if the program's running more than once, like you have a game loop or something. So be very careful when you're using pointers, because it's very easy to create what's called a memory leak, which is where it's basically what would happen if we just took away this delete. This memory that points to the value 10 would be lost, leaked, and we could never get it back until the program ends. So this concept may be a little confusing to you. You may be confused why you need to, or why you ever would use pointers instead of just normal variables, because you don't have to worry about memory management like this with normal variables. The variables just go out of scope and delete themselves. So there really is no use for these the way we're using them now. You'll really never create a pointer to an integer like this. In the next tutorial, we'll get into what pointers are really used for. And that's using pointers to classes and polymorphism, which is a confusing topic, but the name is a bit more daunting than the topic actually is. So we'll get to that in the next tutorial, and in the tutorial after that, we'll take a break and do some easy stuff. So see you in the next tutorial.